Yeah, I know. You've worked with Python, you know what a function is. When you see something like this, you're not scared. You know that x and y are inputs or parameters for this function. But there is something that you've been avoiding. Every now and then you've seen a slash or a star in your function header. And let's not forget the infamous star args and star star kwargs. You've run away from it. But today, you're going to stop running. You're going to face your fears. We're digging into what that slash and star do in our function headers. Let's begin. A function is like a machine. You give it some input, it does something, and then it returns the results. Kind of like this one. Here, our function is called sendLog, and it receives two parameters in between these parentheses, a message and a level. Below that, we can see in the body what this function does. Here, we take the current date time and format it, and later we print the output as a standard log entry. When we call our function, we give the name of the function, sendLog, and pass in the arguments that we want. Here we're passing in an argument of hello world for the message and an argument of info for the level. I should stop here to say that when we define our functions, those inputs are called parameters. Later on, when we call that function, the actual values are called arguments. If you forget the difference between parameters and arguments, it's fine, everyone does it, it's not that big a deal. There's different ways to call a function. Here in this example, we passed in our arguments and Python knew that the first argument should be mapped to the parameter of message and the second argument of info should be mapped to the parameter of level. The order of the parameters matches the order of the arguments. There are other ways of passing in arguments though. Instead of positional arguments, which is what we've done already, we could use something called keyword arguments. With keyword arguments, what you're doing is explicitly saying, hey, this parameter of message should have a value of hello world, and this parameter of level should have a value of info. It works the same as before. It would output another log message, but here we can see more explicitly what values we're passing in. With keyword arguments, you can also mix and match the order. The order doesn't really matter, because when you say that message is this and level is this, you can have the level and the message in different locations, and Python will know which string goes to which parameter. So here, level before message still puts out the same log message. You can also mix and match these two different argument types, the position and keyword arguments, as long as your keyword arguments, in this case level equals info, occur after your positional arguments. Nice, that's a review of the basics of function parameters, but today we're going to the next level to some more advanced function parameter techniques. Let's see what that mysterious forward slash does to our function parameters. Here I'm redefining our sendLog message. I still have the same parameters of message and level, but in between them, I'm putting a forward slash. We can run that and then see what happens when we call our function again. Same parameters or same arguments of hello world and info works just fine. And in this case, I've modified the function so it doesn't do anything. We're just testing to see if the function passes or not. If we try running the same function with keyword arguments, check out what happens. We get an error message, a type error message, and there's a helpful description below. It says sendLog got some positional only arguments past as keyword arguments. And then it tells you message was supposed to be positional only. And that's in fact what that forward slash does. When you have a forward slash in your function header, all the parameters to the left of that forward slash must be received by position only. That is, you can't pass in a keyword argument for message. In this function call, if we delete the message parameter name and the equal sign, this should run. And the reason it runs is because it's only message that has to be positional. Everything to the right of the forward slash can still be keyword or positional. Nice. So you're probably wondering, why would we ever want to force users to only have positional arguments when they call our function? Well, sometimes the order of the arguments actually matters, or is very important. Let's take an example from high school algebra. You might remember that back in high school, you learned about the x and y coordinate system, or the Cartesian coordinate system, and in general, the x coordinate always occurs before the y coordinate. Say we have our function, makePoint, that does something to create a point in this x and y grid. We might have two parameters, x and y, and since we know that on paper, x appears before y, it would kind of be silly to let our users switch things around. It would be silly to let users pass in a y coordinate before a x coordinate. It affects readability and it can make things confusing. To force users to input arguments in a certain order, you can force them to use positional arguments with that /. In our definition for make point, you can see xy and the / that comes after that. Now, if our user tries to put a y coordinate before an x coordinate, Python will throw an error and say, make point got some positional only arguments passed as keyword arguments x, y. That is to say, you got keyword arguments of x and y, but they should be passed into something like this, where your x comes before y and you're not declaring the keyword arguments. Now let's talk about that asterisk. In the same log function, we have our two parameters of message and level, and in between them this time we have the asterisk. We can define this new function and check out what happens as we pass in either positional or keyword arguments. Here we pass in keyword arguments for the message and level, and everything works, it doesn't break. And if we pass in positional arguments, we get a type error. Look at the error message. It says send log takes one positional argument, but two were given. Or in other words, only one of these guys were supposed to be a positional argument. That's because when we have an asterisk in the function header, all parameters to the right of that must receive only keyword arguments. In this case, level has to be a keyword argument, but message can be either keyword or positional. We can modify our function by calling out the parameter name, and if we run this one again, we'll see that the function passes without that error message. The question again is why? Why would we force users to only use keyword arguments? And the best answer I have is readability. Let me show you what I mean. Here's a different function that sends out emails. And you can tell that we have many parameters. We have the person we're sending the email to, the subject of the email, the carbon copy, the blind carbon copy, and the reply to information. There's many parameters here. Suppose that someone called this function using a function call like this. If you read through it, it's kind of hard to tell what's going on. We have Hermione at Hogwarts, I love you, Harry at Hogwarts, Molly, and Ron. It's not clear who is receiving an email, who's carbon copied. You can force users to have more readable code by forcing them to use keyword parameters. You'll notice here we're using a star parameter to force all parameters to be right to be keyword only. What that means is if our user tried to call a function like this, where it's not clear what each part means, there'll be an error message. Specifically, it'll say, hey, you're supposed to have two positional arguments, but you gave me 5. A proper way to call this function would be to clearly indicate the parameters after that star. I've rewritten it here. You don't have to put each of the parameters on a different line, you do you, but I find this to be a bit more readable, and running this function, you'll see that we don't get the same type error message that we had before. Nice, now we know what the slash and the star do in our function header. Let's look at it all together. The slash and the asterisk basically take your function header and break it into 3 different regions. The parameters to the left of a slash can only receive positional arguments. The parameters to the right of the asterisk can only receive keyword arguments, and any parameters that are in between those 2 markers can receive arguments either by position or by keyword. Let's check out different combinations of these function headers. The most obvious one is the one we just saw, where you have a mixture of positional only arguments, positional or keyword arguments, and keyword only arguments. But more commonly, you'll see something where you're explicitly forcing some parameters to be positional only and other parameters to be keyword only, and there's no parameters that can be either or. Another variant is where you're forcing all of your parameters to be positional only. You can see that slash at the very end. And the last pattern is where you force all arguments to be keyword only. Nothing can be passed in as a positional argument. You might be wondering, how do I figure out which one to use? Well, when the order of the arguments is important or meaningful, or maybe you want to hide the parameter names as users call your function, positional only parameters are a good choice. In other cases, you want to force users to write more readable code, or you want them to be explicitly sure of certain parameters that they're passing into their function. In that situation, you can use keyword arguments. For those situations where it doesn't matter, you can use either positional or keyword arguments. And most of my functions are of this third type. In all the examples we've seen so far, you know exactly how many parameters you're going to receive. But sometimes you don't know how many parameters are going to be passed into your function. You might have a variable number of arguments, 1, 2, 3, potentially dozens. In these situations, you can use *args or *kwargs or kwargs. I'm not sure what it's called. I'm calling it kwargs. Here's a simple example. This function has two parameters, x, y, and a third parameter called *args. In the body, we're printing out the value of each of the parameters and the type of the parameter args. Let's run it. You'll notice here that we're calling our function with 5 different arguments, 1, 2, 3, 4, 5. If we look at the output, we can see what our function is doing with these arguments. 1 was mapped to x and 2 was mapped to y. Nothing surprising there. We expect it to receive at least 2 arguments. But the other arguments, 3, 4, and 5, they're wrapped up into a tuple and given to the variable args. We can verify that's true. We printed the type of args and we can see it is, in fact, a type of tuple. So *args, you can think of that as something that eats up any extra positional arguments that the function was not expecting to receive. The function expected to receive an x and a y, and so it gave the first 2 arguments to x and y, and all the other arguments were thrown into *args. Let's upgrade our sendLog function so it can receive extra positional arguments. Here, instead of just message, we have a parameter of *messages. I'll stop here to say you don't have to use the name args. You can use any name for your variable. In this situation, I'm using *messages, so any extra positional arguments will be wrapped up in a tuple and assigned the variable messages. A lot of times you'll see *args and *kwargs as the community accepted standard, but you're free to use whatever variable names you want. We're still formatting our current timestamp and looping through all of the messages that are in our messages tuple and printing them as a separate log entry. Practically what this means is that we can now, in a single function call, send in multiple messages. Running this, we can see that our 3 messages have been properly converted into different log entries with the same timestamp. Let's move on to *kwargs. In this function, we still have x and y as expected parameters, and we have our third parameter as *kwargs. Again, the name could be anything. Kwargs is just the accepted standard. We're again printing all of our parameters and the type of kwargs. If we run this with our function call of 1, 2, and then a few keyword arguments, you'll notice that, again, 1 and 2 are mapped to x and y, and all of these extra keyword arguments are wrapped up into a dictionary where the parameter name is the key and the argument value is the value. And that's what ** does. It takes any extra keyword arguments that are not in the function header and throws that into a dictionary with whatever name you give it. We can apply this to our sendLog message. Our sendLog function now receives a single message again, and any extra keyword arguments are thrown into a dictionary with the name metadata. This might be useful when a different application is calling this function and needs to put in some additional metadata in a clean way. Because metadata is a dictionary, we can perform dictionary-like operations, like looping through the dictionary's items and appending them together as a string, and then later adding that to the end of our message. When we run this, we pass in our message and our level and any extra information we want to include in the message, and the function does the job of properly parsing it and adding it to the end of our message. You can also mix and match your variable positional arguments and your variable keyword arguments. This function has parameters x and y. Any extra positional arguments are thrown into a tuple and labeled args. We also have a parameter z, and any extra keyword arguments are thrown into a dictionary as kwargs. When we call this function, we're passing in some arguments that are not explicitly written in the function header. We have the arguments 1, 2, 3, 4, 5. In this case, we have to use z equals 6 as a keyword argument. That's because z occurs after this asterisk marker. And we also have an unexpected keyword argument of b equals 7. Let's see what happens when we run it. Like before, 1 and 2 are mapped to x and y. Z equals 6 means z equals 6. These extra positional arguments are given to args, and this extra keyword argument is given to kwargs. That's it. That's all *args and *kwargs do. They allow your function to receive extra arguments. And in your function body, you can work with those arguments using that tuple or the dictionary. You did it! Congratulations! Now you know what the slash and star do in a function header. Let's look at all of it together. Here are the 5 parameter types that we talked about. Most of the time when you define your functions, it'll look a little bit like this, where your parameters can receive either positional or keyword arguments. In those situations when you want to force one or the other, you can use the slash to make all parameters to the left be positional only, or you can use the star to make all parameters to the right be keyword only. And when you need to receive a variable number of arguments, you can use star args for variable positional arguments, and you can use star kwargs for a variable number of keyword arguments. Thanks for joining me today. I hope you learned something and you're ready to use the slash and the star in your function headers. It's not as complicated as it seems. If you like what you see, please like and subscribe. If you have any questions, leave them in the comment below. Until next time, happy coding.